Hi guys, welcome back again. Today I'm gonna talk about the ECG or EKG electrocardiogram. Okay, so let's start. Here we have the definition of the ECG is a test that checks how your heart is functioning by measuring the electrical activity of the heart. So as you know, the ECG is an important diagnostic tool that we use especially in the emergency department, and it's important for being able to look for arrhythmias or myocardial infarction or other problems of the heart. So with each heartbeat, an electrical impulse travels through your heart. This wave causes a muscle to squeeze and pump blood from the heart. An ECG measures and records the electrical activity that passes through the heart. A doctor can determine if this electrical activity is normal or irregular. An ECG may be recommended. So this is the indications of the ECG. If we have the experiencing of the arrhythmias, chest pain, or palpitation, an abnormal ECG result in signal of number of different heart conditions. Okay, so simply we have the heart chambers. As you know, the heart has 4 chambers: left atrium, left ventricle, right atrium, and right ventricle. So here we have the heart's electrical system. So as you know, it's important to know that memorize the SA node. This is the SA node and AV node, bundle of His, right bundle branch, left bundle branch, this one, and Purkinje fiber, the last or the terminals branches. Okay, so in order to know, suppose that this is the heart. Okay, this is the right atrium and left atrium, right ventricle and left ventricle. Okay, so here you have the SA node. Okay, so as you know, the heart's pumping action is regulated by an electrical conduction system that coordinates the contraction of the chambers of the heart. So here we have SA node. So what's SA node? SA node is this is SA node. So SA node is a specialized myocardial structure that initiates the electrical impulse to stimulate contraction. So the electrical impulse travels from the SA node to AV node. So here we have the AV node. Here this is another node called AV node. So the electrical impulse travels from the SA node to the AV node. Their impulse are slowed down for a very short period, then continue down the conduction pathway via the bundle of His into the ventricle. So here we have the bundle of His. This is bundle of His. Okay, bundle of His, then goes down, divided into the left and into the right bundle branch. Okay, to stimulate the right and the left ventricle, and finally we have the something called Purkinje fibers. Okay, so this is the electrical impulse, or what we call the heart's electrical system. So normally at rest, as the electrical impulse moves through the heart contracts about 60 to 100 times per minute. Okay, also this is as you know, depending on the person's age. Okay, each contraction of the ventricle represents 1 heartbeat. The atria contract a fraction of a second before the ventricle, so their blood empties into the ventricle before the ventricle contract. Okay, so this is about the electrical system of the heart. Okay, as you know, this is the machine of the ECG. This is called chest leads, and there's limb leads. This is chest electrode all, okay, chest leads and limb leads also. This is a trace, this is the machine. Okay, just to be familiar with this point. Okay, here we have the chest limbs, also the places of the limbs. We have to know V1, V2, V3, V4, V5, V6. V1 at the place of fourth intercostal space to the right sternum. We have to fix it at this point. Okay, V2 at the same level but to the left sternum. V3 midway between V2 and V4. V4, as you know, the fifth intercostal space. Okay, the fifth intercostal space, the fifth intercostal space. Okay, V5 at the anterior axillary line, V6 at the mid axillary line. This is also another picture: V1, V2, V3, V4, V5, and V6. In general, the ECG is composed of 12 leads. Okay, 6 are limb leads, 6 are chest leads. Okay, this is also about the limb and chest leads and the side of leads that we have to fix it. Okay, this is about the axis. Anything between the -13 to -19 called left axis deviation, while the anything between them +19 to 180 is called right axis deviation. Another one is called extremely axis deviation. In order to know, suppose that we have a heart. This is the heart. Okay, right atrium, left atrium, right ventricle, left ventricle. Okay, as I mentioned it, here we have SA node, then here we have AV node, and then distribute to the left and to the right. The direction of electrical impulse. Okay, so you know that here we have lead 1, lead 2, AVF, lead 3, AVR, and AVL. Okay, if the electrical impulse toward the limb, this is the limb lead, and this is the electrical impulse. If the electrical impulse toward the leads, it causes a positive deflection, as we see here at the lead 1, lead 2, and why? Because the electrical impulse toward the lead 1, lead 2, and lead 3, it causes a positive deflection. Okay, it causes a positive deflection here. It causes a positive deflection. Okay, all of them are positive deflection. Here we have second point, which is also it's a lead. If the electrical impulse away from the leads, it causes a negative deflection. Negative deflection, as we see here in the AVR. Why? Because the electrical impulse totally away from the AVR, so it causes a totally negative deflection of the AVR. Okay, the last point about the axis is the third one, which is if we suppose that this is a lead and this is the electrical impulse. When the electrical impulse toward the leads, it causes a positive deflection. When the electrical impulse away from the leads, it causes a negative deflection. Negative, okay, negative and positive deflection, as we see here in the lead 3 and AVL. It causes a positive and negative deflection. Negative deflection. Here we have lead 1 and AVL, AVR, also lead 3, AVF, and lead 2. As I mentioned, here we have a normal axis deviation. When we say it's a normal, when the lead 1 is a positive deflection and lead 2 also a positive deflection. Why? Because the SI node here, and this is the AV or the electrical impulse toward this limb, so it causes a positive deflection here and also positive deflection here, so it's at this range, so it considered as a normal axis deviation. When the lead 1 is positive, okay, when the lead 1 is positive but lead 2 is negative, it means that this is the positive one and this is the negative one, negative lead 2, left axis deviation. So if we have a positive lead 1 and negative lead 2, it considered as a left axis deviation. Why? Because the electrical is toward this direction. Okay, so this is a left axis deviation. So here we have, so the electrical impulse is toward this area. Deviation, right axis deviation, we have when the lead 1 is a negative, it means by this direction, it's a negative lead 1, okay, and while the lead 2 is a positive, it means by this direction, so the direction of the electrical impulse this way, so it considered as a right axis deviation. So as you know, in the case of the left ventricular hypertrophy, it causes a left axis deviation, and in case of the right ventricular hypertrophy, because of a right axis deviation. Okay, so here as you know, the ECG paper consists of the large and small square. Each large square consists of 1, 2, 3, 4, 5 horizontal and 1, 2, 3, 4, 5 vertical small squares. So in general here we have 25 small square. Okay, so each small square is 0.04 second duration as a speed. So but it's important to know the constant speed of ECG paper is 25 millimeter per second. Okay, here we have the amplitude. The normal amplitude consists of the two large square. Okay, two large square or 1 millivolt